To understand this current electricity, the important concept, that is voltage, you have to recall, which you learned in the second chapter. So only when there is pressure difference, the water flows from one container to another container and it flows from higher to lower. Steady current is the ratio of total charge flowing through the cross section of the conductor to the time taken. Hello everyone, I am Maitri, Faculty of Physics, Vidhyaashram, Temple of Excellence, Mysuru. So in this session, let us move on to the next chapter, that is chapter 3, current electricity. Can you imagine living without telephones, mobiles, fridge, laptops, no light bulb, etc. So can you imagine how tough would be that? So this is where the electricity is an incredible invention in science. So what is electricity? Electricity is the form of energy. So in the first two chapters, what you studied is static electricity. What is static electricity? Let us recall that. It is caused by the interaction of two different bodies. When they are in contact with each other, then the charges are transferred from one body to another and remain at rest on the surface. This accumulation of excess of electric charges is nothing but static electricity. Here is an example. Consider a plastic comb, rub with the dry hair. When you rub that comb with the dry hair, the charges flow from one body to another body. From this process, the comb gets charged. When it is charged and brought near the paper pieces, in the paper pieces, the charges rearrange. Hence, this paper pieces attract to this comb. This attraction is nothing but static electricity. Then what about current electricity? To understand this current electricity, the important concept, that is voltage, you have to recall, which you learned in the second chapter. Voltage is nothing but potential difference. What is this potential difference? Consider a battery. A battery consists of electrolytic solution. So in this, the charges separate and electrons accumulate towards one side, making it negative terminal of the battery and the other side as positive terminal. So one side we have more electrons and other side empty space, nothing but electrons are in less number. Now, and here a barrier between these two sides where electrons cannot move from one place to another place inside the solution or inside the battery. When these electrons are in one side and electrons, they are like charges, between the like charges there is repulsion and they are crowded. As they are crowded, they experience high pressure. So they want to move towards the low pressure, that is towards the empty space, but they are not allowed to move inside because of this barrier. So we will connect this battery to a wire. Yes. When we connect the battery to a wire, then this electrons move from high pressure to low pressure side. So this pressure difference makes the electron to move from one side to another side, nothing but potential difference. The potential difference makes the electron to move from one side to another side. To make you understand, here is the picture. So imagine you have two containers filled with water to different levels. One, let us consider it as A, another one as B. As the water levels are at different levels, So from the level which is high, the water start to flow to the level which is low. Means this water level which is high has the high pressure. High pressure, and the water flows towards the low pressure. Because of this pressure difference, water start to flow and it continues up to the level is equal. Up to it reaches the same level. So only when there is pressure difference, the water flows from one container to another container and it flows from higher to lower and it reaches the same level. When it reaches the same level, it stops there. Yes. Then to create the pressure difference, we have a pump which continuously maintains this water level at different levels. Yes. Same way, this pump, what it function, the same function is done by the battery. Here the battery continuously maintains the potential difference for the electrons to flow from one terminal to another terminal. That is from higher potential to lower potential. Only when there is potential difference, then electrons flows from one body to or one point to another point. This flow of charges is nothing but current electricity. So what is current electricity? Current electricity is the flow of charges. Yes. So here is another example. Consider a conductor. You know conductor. Conductor consists of number of free electrons. So what are conductor? Conductors which allow current to flow through it and it has number of free electrons. And these free electrons are in random motion. They are in random motion. As they are in random motion, so total current in this is equal to 0. Total current in this is equal to 0. Yes, now what we'll do? We will consider a circular plate which is charged to positive and to negative. So this is positive charge and another plate which is negative charge. Bring that circular plate and attach to the ends of this conductor. When you attach to the ends of the conductor, you are creating an electric field in this conductor. Now, electrons are in electric field and due to this electric field, electrons experiences the force and they start to move towards the positive charge, opposite charge, and they neutralizes this plate. Therefore, this current is for short interval of time. But I need continuous constant current. For the continuous constant current, we need continuous potential difference. That is by the battery. So, when you connect this conductor to a battery, there will be continuous constant flow of the electrons, which is known as steady current. What is steady current? Steady current is the ratio of total charge flowing through the cross section of the conductor to the time taken. This is the equation for the steady current, that is I is equal to Q by T and Q is given by quantization rule, that is NE. And what is the SI unit of current? The SI unit of current is ampere and it is denoted by capital letter A. The symbol of SI unit of current is A. Now let us know the direction of current. How to represent the direction of current in the circuit. So the direction of conventional current is opposite to the direction of electron flow. So always electrons flow towards the positive terminal of the battery. The opposite direction for this is the conventional current which we have to mark in the circuit. So, the conventional current direction is from positive terminal of the battery towards the negative terminal of the battery. Next, and current is a scalar quantity. Even though it has magnitude and direction, we consider the current has a scalar quantity and we follow the law of scalar addition, not the law of vector addition. Why? Because the angle between the wires carrying the current does not affect the total current, as in this picture. You can observe here, the current in the wire is 5 ampere and in the another wire is 3 ampere. Then the total current in the wire is 8 ampere, where we have followed the normal addition. And consider the second example here. The current in this wire is 3 ampere. The direction is given by drawing the arrow. And current in the wire B is 4 ampere. Then the total current in the wire C is, follow the normal addition, 4 plus 3, which is equal to 7 ampere. Even though it has direction and magnitude, current is a scalar quantity because this angle between the wires does not affect the total current in the wire. These two quantities, that is potential difference and the current, leads to a very important law, that is Ohm's law. What is the statement of Ohm's law? The electric current through a conductor is directly proportional to potential difference across the ends of the conductor, provided the temperature and other physical condition remains constant. So according to Ohm's law, potential difference is directly proportional to current, and the proportional constant is R, where R is known as resistance. R is known as resistance. This is Ohm's law. According to Ohm's law, as V increases, let us know that as V increases, observe in this picture, we are increasing the V. As V increases, look at the I also increases. But R remains constant, which is the proportionality constant known as resistance. So, as the V increases, I increases, but R remains constant. For the R to be constant, you have to write the condition. The condition is temperature and other physical conditions remains constant. This is Ohm's law. So, according to Ohm's law, the equation is V is equal to IR. Yes, next, what is resistance? What is resistance? Resistance is the opposition offered by the conductor to the flow of current. Opposition offered by the conductor to the flow of current. What opposition? In what form the opposition is in the conductor? Let us know that. So, consider a conductor. You know that conductor consists of free electrons. And along this free electrons, inside the conductor, there is positive ion. Positive ion. When these free electrons are in motion, random motion, these electrons collide with this positive ion. When they collide, this collision itself is the opposition for the current in the conductor. Current in the conductor. So, this opposition is nothing but resistance. In what form the opposition is? In the form of collision. Collision between the electrons and the positive ion is the opposition for the flow of electrons in the conductor, that is itself the resistance. So, what is a resistance? Resistance is also defined as the ratio of potential difference across its ends to the current flowing through it. And the formula for the resistance is R is equal to V by I. And the unit of resistance is ohm. Its symbol is this, ohm. The SI unit of resistance is ohm. And what is the circuit symbol of the resistance? The circuit symbol of the resistance is given here. Note down, this is the circuit symbol of the resistance in any circuit. Then define 1 ohm. After defining a quantity, we have to define its SI unit. Now let us define its SI unit, that is 1 ohm. To define this SI unit, let us consider the formula R is equal to V by I. When this R is equal to 1 ohm, when the potential difference is 1 volt and the current is 1 ampere, then the resistance is said to be 1 ohm. Same you have to include in the statement. The resistance of a conductor is 1 ohm. If a current of 1 ampere, how much should be the current? The current should be 1 ampere flows through the conductor when the potential difference is of 1 volt. Potential difference across the conductor must be 1 volt and the current must be 1 ampere. Then the resistance is said to be 1 ohm. This is very easy one. Next. The devices which obey Ohm's law are known as ohmic devices. Examples are resistors. This is the resistor. Resistors are the examples for the ohmic device. What is ohmic device? The device which obeys Ohm's law. And define non-ohmic device. Opposite to the ohmic device is non-ohmic device. It is the device which does not obey Ohm's law. Examples are semiconductors and transistor. Means in all this device, V is not directly proportional. Not directly proportional to current. V is not directly proportional to current. So then such devices are known as non-ohmic devices. Let us understand how the resistance depends upon the length. For that, consider a conductor of length L, area of cross section A. To this conductor, let us connect a battery of potential difference V. When the battery is switched on, the current I start to flow in the circuit. Now in this, length of the conductor is L, area is A, voltage is V, current flowing through the conductor is I, and the resistance of this conductor is R, which is given by V by I. To this conductor, an identical conductor, let us place to next of the conductor. So the same conductor, take this, place an identical conductor next to this. Therefore, now the length of the conductor, which is of 2L. So now we have two conductors, conductor 1 and conductor 2. They are attached to each other, next to each other. So they are identical. So the length of the combination is 2L, but the area of cross section remains same. And the current through this combination is I. The same current flows in the conductor 1 and conductor 2. As the same current flows, the potential difference across the conductor 1 and the conductor 2 is V and V because the same current flows in the conductors. Now, for this combination, length is 2L, area of cross section remains same, but the voltage across this combination is 2V, across the combination is 2V, and the current in this combination is I because they are identical, and the resistance of this conductor, the resistance R is calculated by V by I, where V changes, therefore R changes. R changes. Let us substitute the V. V is 2V divided by I. So change in R is given by 2V by I, where V by I is R, that is initial resistance. Therefore, here the new resistance is equal to 2 times of initial resistance as we increase the length to 2L, from L to 2L. Therefore, as the length increases, resistance increases. The next factor is area. How the resistance depends upon area. Let us know that. Consider the same conductor of length L, area of cross section A, and connect a battery of potential difference V to this conductor. Now the current I start to flow in this conductor and the conductor resistance is V by I. So what is the length? Length L, area of cross section A, potential difference is V, and I is the current, then resistance is R. In the second case, that is, this conductor is divided into 2. When we divide this into 2, then the area decreases. So area decreases. Area becomes half of the initial. So area changes. Length remains same. And this combination is connected to a battery of potential difference V. So potential difference V. The current I flows when this combination is connected to battery of potential difference V. Now observe here, these two pieces of the conductor are connected between the same 2 points, nothing but the parallel combination. So as they are connected between the same 2 points, across the 2 conductor, the potential remains same, but the current divides. Current divides into I by 2, I by 2. So current divides. So current changes in this case. Now what is the resistance? The resistance R dash is equal to V by I, where V remains the same. I becomes half. So what is the final value? 2V by I, where V by I is initial resistance R. So the new resistance is equal to 2 times of initial resistance. At what condition it is? Look at L. L remains the same. Area changes. We have decreased the area. Potential remains same. Current I has decreased when the area decreases, and observe the R. R has increased. When the area decreased, R increases. Now what is the relation between the resistance and area? Resistance is inversely proportional to area. Resistance is inversely proportional to area. As the area increases, resistance decreases, or area decreases, resistance increases. Yes. What are the two quantities on which the resistance depends? Resistance depends upon the length. Resistance depends upon the area. Now observe this picture. Can you tell me which has the greater resistance in this two? Which has the greater resistance? Yes. First let us consider this and consider this. Compare these two conductors. The length of the conductor is same, and observe the area. The area of first one is greater than the second one. So here the area as A1, consider this as A2. So A1 is greater than A2. Length is same, area is different, and you know how the resistance depends upon the area. Resistance is inversely proportional to area. If area is less, resistance is more. If area is greater, then the resistance is less. So for which conductor the resistance is less? For the conductor which has more area has the less resistance, and for which the area is less has the more resistance. So let us consider this as R2 and this as R1. So R2 is greater than R1, as resistance of a conductor is inversely proportional to its area of cross section. The next quantity is length. Now observe the same two conductors. For the first conductor, let us consider the length as L1 and the second conductor length as L2. But the area remains the same. Area remains the same. Now in this case, which one has higher resistance or greater resistance? Yes. You know the relation between the resistance and the length. They are directly proportional, and in this case, L2 is greater than L1. Therefore, R2, that is the resistance of second conductor, is greater than R1. Second conductor is greater than R1 because the resistance of conductor is directly proportional to length. Resistance of conductor is directly proportional to its length. So, on what factors the resistance depends? Resistance depends on material, length and area of cross section, and temperature. The third quantity on which the resistance depends, let us discuss later. Now you just know the factors on which the resistance depends. One is type of material, like whether it is copper, silver, the material. On this material also the resistance depends. The next factor is length and area. You know how it depends upon length and area. And the third factor is temperature. So how the resistance depends upon length and area? Resistance is directly proportional to length and inversely proportional to area. The proportionality constant is nothing but resistivity, which is denoted as rho. So what is the formula for the resistance? Resistance R is equal to rho L by A, where rho is resistivity of the material. What is conductance? Conductance is the reciprocal of resistance. Conductance is the reciprocal of resistance, whose SI unit is Simon. The symbol of the SI unit is capital S, and the symbol of the quantity is G. Capital G is the symbol of the quantity G. Yes, next. Consider this R is equal to rho L by A. Using this, let us define the resistivity, which is also known as specific resistance. What is resistivity? In this formula, consider the length as 1 meter and area as 1 meter square. Then R is equal to rho. What is R? R is the resistance. So, resistivity is nothing but resistance offered by a conductor. What should be the length? Length should be of unit length and area should be of unit area. Unit area is nothing but resistivity. Resistance offered by a conductor of unit length and unit area of cross section is called resistivity. The SI unit of resistivity is ohm meter. As the length, okay, consider the formula R. R is equal to rho L by A, in which rho is equal to RA by L. What is the unit of resistance? Is ohm. Area unit is meter square and the unit of length is m. One of the meter get cancelled. Therefore, the unit of resistivity is ohm meter. The next quantity which we need to define or related to resistivity is conductivity, which is denoted as sigma. Sigma is the reciprocal of resistivity. The definition of conductivity is that the reciprocal of resistivity. SI unit is per ohm per meter is the SI unit of resistivity. So in this session, you have learned about the Ohm's law, resistance, resistivity, on what factors the resistance depends and how the resistance depends upon the length and area. In the next session, let us continue with the drift velocity and the conductivity. Thank you.